Today we're looking at area under a curve specifically as it relates to definite integrals. So I want to just point out a couple of things here to make sure that we have all the details and all the concepts in line in our head in order to be able to find these, okay? So first of all, notice the definite integral of f of x from a to b gives the area bounded by the curve of x, of f of x, the x-axis, and the lines x equals a and x equals b. So we're finding this integral from a to b of our function. That's going to give us the area. Okay? Now two important things really before we actually do an example. The first thing is make a sketch. Make a sketch of the function. That's what we learned parent functions way back. We've been working on graphing functions. You've got to know what you're dealing with in order to be able to really understand what area you're trying to find. Okay? Secondly, make sure you actually write down the integral that you're going to find. Okay? So, here's an example. We're going to find the area of the region enclosed by y equals x squared plus 1, the x-axis, and x equals 1 and x equals 2. So the first thing that we're going to do is sketch this curve. We have y equals x squared plus 1. So it's got a y-intercept at 1. It's going to go through the point 1, 2, and the point 2, 5. Okay? It's going to be a parabola here. And then what it's asking us to find is this area here. Bounded by the curve itself, the line x equals 1, the x-axis, and the line x equals 2. Alright? So it's almost a trapezoid, but since this side is curved, we can't just treat it as a trapezoid. So we have to use an integral. So, what's the integral we're going to find? Okay, the integral from 1 to 2 of x squared plus 1 dx. Okay, on every problem, I want you writing out the integral that you're finding. Okay, don't just jump right in. This is an easy way, especially like on the IB exam, they're going to want to see that. It may not be required, but if for some reason you mess up the integration, you'll at least get a method point or a reasoning point. Okay? Because you set the integral up correctly, you just may have messed up finding the integral. Okay? So show that work. Now though, what is the integral of x squared plus 1? So that would be a no-brainer at this point. Okay? Integral of x squared plus 1. 1/3 x cubed plus x. Okay? So we're evaluating this using our fundamental theorem of calculus from 1 to 2. Okay? This is our antiderivative, the capital F. So we're going to do capital F of 2. So we plug in the 2 minus, good, capital F of 1. So here we have 8/3 plus 2, which is 4 2/3, minus 1 1/3. So we get 3 1/3. Okay? We get 3 1/3 for our total area. So that's not too tough, as long as we remember our integration rules. Now, the only time when these can get a little bit tricky is when we're asked to find an area, but they don't specifically define what our interval ought to be. Okay, for example, here we're asked to find the area enclosed by one arch of the curve y equals sine of 2x and the x-axis. Alright, so in this case in particular, we need to make sure that we write down a sketch of our graph. Okay? So going back to what we remember from trig, how would we sketch sine of 2x? Where does it start?
0,
0,
0.
0. Okay, it's not translated anywhere. You don't see any pluses or minuses in there. So we're starting at 0, 0. What does that 2x do? It compresses it horizontally. So where are we going to end? Normally it's 2 pi. Now it's just pi. Okay? So we're going from 0 to pi. We're going to go up to 1 and down to negative 1. So up to 1, down to negative 1. Halfway through we're going to hit the x-axis again. Okay? And this value is at pi over 2. Okay? So in this case, we know we're finding the integral of sine of 2x, but what interval are they asking us for?
You have to go from 0 to pi over 2. From pi over 2.
Well, actually, only half of that, because it didn't ask for one period, it asks for one arch, okay? Now, the reason why we only need to find one arch is because, think about this, if area above the x-axis is positive and area below is negative, what's the area from 0 to pi going to equal? 0. The net area, okay? Now, if you wanted the actual area, it'll just be that doubled, okay? But when we find the integral, if you were to take the integral from 0 to pi, you get 0. Because there's an equal amount of area above the x-axis as there is below the x-axis. So we get a net area. But here we're just going to go from 0 to pi over 2. Okay? Take a moment or two, try to integrate that and evaluate it on your own. If you don't remember your rule for sine, you go back and look it up in your notes. What's the integral of sine of 2x? The integral of sine is negative cosine, so it's negative cosine of 2x times 1/2. There we go. We got this too. It's a cosine of a linear function, so we've got to account for that. So it's negative 1/2 cosine of 2x. So we evaluate that from 0 to pi over 2. And these are both on the unit circle. So this is, I would expect to see something like this on a non-calculator part. So if I'm evaluating at pi over 2, I'm actually taking the cosine of pi. 2 times pi over 2 is pi. What's the cosine of pi? Negative 1. Okay. Minus negative 1/2 times the cosine of 0. What's the cosine of 0? 1. Okay. So this is a positive 1/2 plus 1/2. So the area under one arch equals 1. Okay. So in this case, the interval wasn't explicitly given, but we could figure out what it was. Okay. We're going to look at another case where it's not explicitly given in our next application, which is finding the area between two curves. But that'll be not till Thursday. So. All right, are there any questions? All right, I'm gonna stop the video there.